Yes.
All yours, Prema. Go ahead, please. Thank
you. Yesterday, when we had the session, we saw the basics of R, and we saw how arithmetic numerical values are input into R programming. We've seen how we assign a value to an object in R, and we've also seen how to create a vector using the concatenate symbol, which is assigning not just one value, but a number of values. We've seen the different data objects that R has, and of the data objects, what are the different data types in each of the data objects that we have, like complex numbers, raw numbers, integers, and stuff like that, logical numbers and stuff. We'd also seen what are the default ways of importing data into R, and what are the two different files that R actually by default allows, which were the tab delimited and the CSV file. Then we've seen some metamodel commands, which are quite important, like trying to understand what the string commands, the dim command, what do they do and stuff. Then we've seen more of graphical representation, which we're going to study in detail as of today, and also how we convert from logical to numeric, numeric to categorical kind of data and stuff like that. So we'll look into all of this using data today. So first, we've seen how to assign a single value to an object in R. And I've assigned x equal to 10, and I've asked it to print. And I'm getting, so we've seen the characteristics, which is what the first thing was. R is case sensitive. So if I say capital X, it's going to tell me there's an error in object X because R is case sensitive. The two ways I can assign values to objects now. One is using the equal to sign like I've done here. The other way is to give instead of the equal to sign, I can do the less than sign and just a dash and assign a value. That's the other way of assigning values. And it's just a matter of preference as to what one would really want. Then the second characteristic that we'd seen was R overrides objects. So I said y is equal to 8, and now I'm saying y is equal to 7. So in my workspace, you see y is equal to 7 and not 8. So it overrides if I did not save them. ls command is just to show you about what is listed in your workspace. It just shows you the two objects, names x and y, in your workspace. rm command is to remove the object y, and it will remove the object y. Now I want to get it back again. Okay. Now the next characteristic that we've seen was that when you assign a value to an object, the object name should always start with a character, not numeric. And it can succeed by a numeric after that, but it's got to start with a character. Sorry. Somewhere here. Okay. Okay. Why does it do this? Yeah. Sorry, just hold on. Start 1 and x. I don't know why is it doing this to me. Sorry about this inconvenience. I think I'll just get that sorted in a little while. Okay. Okay. I'm going to get this removed here. Okay. So when I run this, it's going to run it for me. And when I say x is what is the value of x.1, it will give me 13. Okay, so when I assign character values, so, okay, sorry. Now if I say 1.x is equal to 13, and I want to run it, it will say unexpected symbol in 1.x, because your character, your objects in R should always start with a character and not a numeric. That is the third characteristic that we've seen. The fourth was assigning character values to objects in R. When I assign character values to objects in R, I always assign them using the double quote. When I assign numeric values to objects in R, and I do a double quote, R will treat it as a character value when performing arithmetic operations on them. Okay. The next we'd seen was, what are the different ways we can perform arithmetic operations now? So those were the four characteristics that we'd seen in R yesterday from the theory perspective. After which we moved into seeing what are the different, you can add, multiply. We stored a value in X and Y in the previous session that we've seen here. Y is equal to 9 and X is equal to 13. So let's do some arithmetic operations on them. Okay, fine. I'm not going to do that then. X is equal to 2 and Y is equal to 3, let's say. Now I'm going to perform some arithmetic operations on this. X plus Y. Y is done.
Should we not have the cursor on for line 14, maybe?
No, I think yeah, okay. Now I got it. I didn't run the command, sorry. Okay, X is equal to 2 and Y is equal to 3. Now I can do addition. X plus Y is 5. I can do, I've just assigned the object name. I can subtract. I can multiply. Right, I can take the square root of Y. Right, I could use the log command and exponent anti-log. Okay, let me do the log of 2, let's say. I get the value. Can do a, yeah, I've run the square root command. So different operations we can see from a perspective of arithmetic operations. How to create a vector in R? I could create a vector using the concatenate symbol, which is what it is here. And it's nothing but assigning many values to one object in R. I could also create a vector of character objects, not just numeric objects, which is what I've done here. Okay. I could use the repeat command to actually repeat a sequence of numbers the number of times I want. If I want to repeat number 1 10 times, I could give a command like this. It's going to do repeat 1 10 times. And I could also repeat not just a numeric, but also a name if I wanted to do. Or sequence of numbers. If I wanted from 2 to 5, I can, and it's divided by 1 or multiplied by 1, and I can repeat it 5 times. So on with character objects. I could also perform arithmetic operations on vectors too. And we'll just have a look at this. Okay. What I'm trying to do here, we have a vector x, and we want to take x and add 10 to every element. That's what I'm doing here. I'm subtracting and I'm multiplying. Okay. We've seen this, we've seen this. Then I want to show you how to use the importing data into R using the different ways of the different files that we have in R. How do we import that data? We've got two files called the comma-separated file and the tab-delimited file. Now, how do we import a comma-separated file? Using the CSV command, read.csv command. First, I'm going to ask for help for the CSV, read.csv, and I get all my documentation of the syntax as to how I write the syntax. Look into all the different functions here. Or the other ways, I can just give a question mark and say read.csv, and either way, it's going to do the same thing for me. Now, the first way of doing it is, I say read.csv, and I say header is going to be 2. So it's going to pop up and say, where is that file stored? Go and import that data. Okay, it will pop up that for us. The other way of doing it is read.table command. When I run this command and I separate it by a comma separated file. It'll again pop, say, where is your file stored? Go and import that file. Now for a tab delimited file as well, I use the read.delim command, and it again tells me go and find your file and get it imported. The other way of doing a tab delimited file is using the read.table command separated by a That's the other way of doing it. So these are the different ways of importing data into R. Now let's have a look at some of the Metamodel commands in R. The dim command, I'll import a data set for working with it. Okay. I'll import a basic data set. Okay. Where would I go? My desktop. Let me see if it's here. No, it is not there. Okay, it should be here. Not that content. Okay. Session 1. Okay, let me import a CSV file. Okay. I've got a data set which I've just created for working purposes. With 29 observations and 6 variables. This is my data set that I have here. We're just going to do some basic operations. I want to know what is the number of rows and columns. I give the dim command, and I get 29 rows and 6 columns, which is what it is, 29 observations and 6 variables. The head command will give you the first 6 rows of the data, and the tail command will give you the last 6 rows of your data. How to check the variable names? When I give the names command, I get all the column headers of my data set. And how do I use the $sign to extract the variable? Now, every time I want, if I say, give me the mean of my age column, it will not give it to me here. It's going to say object age not found. But actually, there is an object age in my data set. The reason being that I have not attached my data set. In R's memory, it doesn't know which data set does it need to go and pull the age column from. So it will not be able to do it for me, so it gives me this error. Now the same command I'm going to do give me the mean, not just of age, give me the mean for this data set, which name is data set. From this data set, give me the age column mean. It will do it for me here. The reason being that I did not attach the data set here. That's the reason I have to call in the data set name and then call the column name before I actually just go ahead and give the column name. So that's when the $ comes into place. But if I didn't want to if I just wanted to give the column name, I have to attach the data set. Again, when I say give me the mean of age column, it will say object age not found. So okay, now I go and attach it here, and then I say give me the mean for the age column. It will give it to me now because I've attached it. See the way I've given the command here and see the way I've given the command here. It's just the same thing. I've got the same output, but because of the attach, I didn't have to mention the dataset name. I can go detach the dataset using the detach and attach it back again. When I'm done with working with the dataset, I can detach it and I can attach it back. Okay. I want to check the class of the ages. It's all integer. What are the levels for gender? It gives me 2 levels. I want to use the summary command for the data set. Sorry. Okay. Give me a summary of all the mean, median. We haven't covered these statistical concepts, but we will do them. And for the categorical variables like for numerical variables like age, blood sugar, and age, it is numeric, so it will give you numeric values. For physical activity, obesity, and stuff like that, which is categorical, which is like yes, no, it will give you the categories with which they fall in. What are the frequencies of their occurrences? Let's have a look at converting data. Where is my conversion of data? Okay, fine. Okay, let's look at some visualization. I want to install a package. I just go and say help and install packages. It'll give me a repository for the local files and all that here. And I want to go install this particular package. It's actually installed on my system, and it'll be doing the install unexpected input in install packages. Okay. Is it, let me just have a look, is it API? API, is it? Yeah, okay. Okay. Is that capital? Okay, fine. Let me just go and see if it's got installed here. Okay. Install the installation. Install packages. Okay. Yes. Okay. I'm just going and updating all of it. So that's the way we install packages now. So the APR package is actually installed. I'm not going to actually work with it at the moment. I was just trying to show you how to install that package. And how to remove a package. You give remove.packages and remove that package if you want to remove it. I just want to plot some graph on the data that I have to hand. So I ask for help and the bar plot command or the question mark, and it give me all the syntax, our documentation relating to bar plots and how do I plot it. Now, when and why do we use a bar plot? It plots the frequencies for each categories of a variable. Also gives me the relative frequencies for each of them. So now, because I have a data set, gender, okay, I'm gonna table. Is my table here? Okay, it's not a table, it's gender. It's a data set. Gender. I'm trying to ask it to give me the cannot find function data set. It is attached. That's the way to give it, right? Okay. Okay. Let's type that. Okay. And give me a table for the gender. Not find function table. Count. Okay. So I've asked it to give me the count of from the gender column in my data set, the number of the frequencies of each of the gender. And it gives me that it is 14 female and 15 male. And I'm getting the percentages. It's 1.4 and 1.5. I want to plot a bar chart for this. Of count. Bar plot of count. Sorry. Give me the bar plot. Percentage wise. Okay. I want to add a title to my bar plot. Could do that too. The percent is main is title. Okay, I'm just giving a title. I'm also labeling my x-axis and my y-axis. X-axis is what lies. I will show it to you in a little while. Okay. This command. Sorry. Okay. So it's actually given the main as title. It's labeled my x-axis as gender, and it's labeled my y-axis as the percentage. Okay. And also to produce a pie chart again. Pie chart. Okay. Okay, so I've just got the, I'm just trying to see what's the function for pie.chart maybe. Yeah. So it's just given a title for the, I haven't done a box plot construction. So I think, most of the practicals from the theory that we've studied yesterday, we've seen. I also want to show some commands for how to convert stuff, and just give me a little bit while I find that for us. It is not in the data set, it should be in basic. No. Okay, I didn't have it here. Okay. Let us also look into conversions. Okay. Okay. I have the iris. Okay. Using a data set called iris, which is an inbuilt data set, is again, let me call the function. If you can see, iris data set's got about, let's go and view the data set. Okay. Okay. It's got sepal length, sepal width, petal length, petal width, and the species Setosa, Virginica, and versicolor. They're the three species of flowers, and for each of the species, we have the sepal length, sepal width, petal length, petal width. Let's just go and see some of the Metamodel commands, like the names command. It gives you the column headers. The strings command give you the depth of observations and the breadth of variables. Species is a factor with 3 levels: Setosa, versicolor, virginica. The others are all numeric values, which can take infinite. The dim command will tell you it is a data set with 5 columns and 150 rows. The categorical variables gives you the number of observations which fall under each category, and the numeric output gives you the basic statistics, descriptive statistics. When I want to plot a graph, of course, the data is not looking very fine here. And I've just color coded it here, nothing more than that. I'm checking if there is a missing value in iris data set, and it says there is no missing value for each of the 150 variables. I want the sum total of all the missing values. It says there is 0 missing values in the data set. So is this for questioning? Is there a missing value? What is the sum total of missing values? Is there? So is is used for questioning in R, as is used for conversion. I'm going to do some commands for as in a little while. Sorry, it's not here. Okay. I want to convert a numerical variable to a categorical using the as factor command. As I just said to you, as is used for converting. I've created a vector of values using the concatenate command. I've asked for class of X. It tells me it's a numeric. I want to convert that numeric to factor. So I say, give an object name X, and I say, I use the as factor command, and I say, convert this vector of X into factors. And I ask, what is the class of X now? It says it's a factor. Give me the summary. It gives me the summary that 0 has appeared once and 6 has appeared, and 0 has appeared 6 times and 1 has appeared 7 times. Here. So why is this very useful to convert at times? Because some of the machine learning algorithms will want the numeric output, but in discretized format. Like I was discussing yesterday, an algorithm like naive-Bayes will want a numerical value, which is just this, but in a format like this, which is also numerical, but it is converting them into factors, discretization format. So as is used for conversion, I'll also try one more of converting logical to using the 1 second. Okay. Also do this for you. Okay, now we've just imported some data into R. Okay, let me import it for us. Okay, the command, and I attach my data set. Line data set. File.choose. Sorry, okay. Okay, so I say it is attachments or content, my business, let's say data set. Open that for me, which is already there. Okay. Names, the head, the age. I've just taken the age column of this data set that I have. Where is it? I've taken, I've done a CSV. Okay. Keep it too. Okay. Oh, tab delimited file. Okay. Let me go and do a CSV file. Okay. 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 Just a CSV, okay. Data 1, okay. That's fine. Where am I? I'm lost. Okay. I go ahead and not a data set, it is data 1. Attach data 1. Attached it. And for names for data 1, it gives me the names. I want it for the head for data 1. It gives me that. Or the first 5. I want the first, from the age column, I'm asking it to give me the first 5 values. 22, 25, 30, 35, 40. 22, 25, 30, 35, 40. Then I've just created a variable, and I want to know if age is greater than 35 for the first 5 columns. That's the criteria. So I want to turn true or false indicators into 0 and 1 in R using the asNumeric command. For this condition, if age is greater than 35, true or false, I want to convert that into 0 and 1. So I assign the asNumeric to age greater than 35. And I get the output as, I want them in numeric values. So it says it's false, false, 0, 0, 1, which is true. So only the number 40 is greater than 35. So is is used for questioning and as is used for converting from one type of this thing to the other type. So these are the basic commands that I wanted to introduce you to R, and there's a lot of practice that needs to go into them. And I will share all of this in this format that it needs to be actually practiced, like wherein, you can just have access to the file and feel it and run the commands and see for yourself. Apart from just running the commands, it's quite vital that we type in the commands so that, we can get a feel of it. Because of the case sensitivity and how the command actually needs to be written. And there's loads of help that you can actually get from here, as it's just been trying to show you. So I would really request that, most of the participants, all of you, most of the time you do need to get a grip of it. And the only way to get a grip of it is via practice. It's just not about running the commands because it's all out available for you here. But I would expect that the commands are actually inputs, so you get a feel of it really. So I think I'll end it. I'll end the session today here, and I would like to take on any questions that you have for me, please. Hello. Any questions? Karthik?
Hey, Prema.
Hi, Karthik here.
Hey, sorry. I had to step out. This week has been very, very, very busy.
Okay.
So I was trying to, but this is good. What I saw today was a lot more progress on how we're understanding R, pulling data from external sources, analyzing. I think it's all about sitting, going back through the videos again and trying to practice on it.
Yes. No, I'll actually give out these files. I can send them out for practice to happen. If
Yes, we definitely would need that.
Yeah, I will send it
To
out.
be sent across, including as you discussed the installation instructions and how we set up our studio.
I will send out all the PPTs as well. If we've got a shared drive or something, Karthik, I can just send it across there, because if I just send it to your email,
Oh,
it's
did I
much.
not? No. We have a drive. I
Yeah,
won't put it there. In fact, all the trainings, we have it. So let me create, where is, oh, data sciences is there. Oh, but
yeah.
this is
It's there,
different.
right? I can upload all these files,
Yeah,
so participants can actually have an access to all of them as and when,
data sciences with R. So I just created one and I'm sharing you.
Okay.
Can edit Prema. And I think I'll need your email address. Let me put that link
Okay.
in your chat
Yeah, please do that.
on Skype.
Yeah.
Right? So we could start putting data into it.
Yeah.
Content. All right, great.
Thank you so
Thank you,
much.
Prema. Thank you, everyone. We'll see you back tomorrow, all of you. Bye. Have a good day. Bye.